Welcome back. It is day 110 or maybe day 111. I'm not exactly certain. We're going to do a weird chunk of time today. It's probably going to be 40 minutes, to be honest, just because we're a bit short on time. And it just happens to it just happens to work like that sometimes. But yesterday we were doing the weekly contest. It went okay, but we'll have to see. I also started on some stuff yesterday, so that is progressing as well. And then we have I'm like fresh off of I literally just woke up, so I'm just fresh off. I'm not gonna get a ton of morning time today, but they're gonna try and focus up anyway. But either way, some days be like that. We have a comment from Botea Public, absolute banger. Get this guy to 500 subs. Get Botea to 200,000 subs. We have another comment. This comment is a bit random, but I just have a question for you. I've been trying to start coding on and off for the last 3 years. Now, ever since all my friends went to college. Hang on. I feel like this is a good comment, but I feel like I want to respond to this, but I feel like since we have so little time, I'm good because I only have about 40 minutes. We have so little time. I feel like the answer won't be good, so I'll try and I'll pre-read it today, and then I'll try and have a good answer tomorrow. But yeah, I don't want to give a random 15-second answer because I ended up waking up a little bit later today. So I think I'll answer tomorrow, and I think I have something better to say. But we're gonna jump into it. To the LeetCode. We had 40 minutes on the clock. And yeah, some days, today is one of those days where it's just a battle. So you have a ton of problems to do. And yeah, let me see if I can queue up some problems. We have that one. We have ugly number, which I think had to do with something we skipped because of another issue. And then I think we should just be able to go from range some. Okay, so we'll start with this one, and we have 40 minutes, so let's just jump into it. Yeah, and there's a lot changed on LeetCode. Like, this whole thing looks just crazy. So case one. So we have given an integer array nums. Handle multiple queries of the following type. Calculate the sum of the elements of nums between indices left and right inclusive, where left is less than or equal to right. Implement the num array class. Num array initializes the object with integer array nums. In sum range, returns the sum of the elements of nums between indices left and right inclusive. Okay. Constraints. Nums.length is less than or equal to 10 to the 4. It's always going to have at least one element. The values are going to be between negative 10 to the 5 and 10 to the 5. 0 left. So left minimum. A right will at least at the minimum be greater than or equal to left. And at most 10 to the 4 calls will be made to some range. So let's look at an example. We have num array, which is this. And then we have some range 0, 2, 2, 5, 0, 5. And the output should be sum between 0 and 2. 0, 1, 2 is 1. 2 and 5 is 0, 1, 2, 3, 4, 5. Looks like negative 1. And the whole thing is negative 3. Yeah, I mean, this one seems pretty straightforward. It seems like we would have a nums array. Key bindings aren't working. Maybe it's because they just updated this. Then if we wanted to sum the range, we would just start from sum equals 0, left going up to and including right dot each do idx. You would just say nums sub idx sum plus equal nums sub idx. Ah, they're saying that is unacceptable. So what we're just doing is iterating over it. So I guess what we could do is also save our responses. We could also save our calculations for the range. But let's think about what the time complexity could be. First, you have an array, numbers. We're calling some range up to. We'll send to the 4 calls we made to some range. So I guess we should hope for at least we'll send to 4 calls we made to some range. So I guess we should hope for at least somewhere near constant time for the sum operation. Maybe within the initialize operation we can do some saving, simplify the sum range operation. What if we used cache and we saved a range that we calculated? That way we'd be optimizing for how many different calls of some range we could get. So we could say something like this, right? Key is going to be equal to left, right, going to right. We'll say if hash or if say it at cache dot key then we'll just return at cache sub key, else if we don't have it right, we'll calculate it and then save that value in the cache. So we see at cache sub key would be equal to sum. Yeah, I guess this wouldn't save that many calls. The calls would all have to be very similar. $496, 9654. If add cash dot key question mark key return. I can't see a better way to do this than to actually sum the range. If we sum the range, can we save? How can we save it for how can we save some data to make it easier to copy future ranges? How can we save some data to copy future ranges? $517. So if we calculate the range 5179958, which is right here, we're reusing a lot of the same ranges, as you can see, except we're redoing a lot of work. Wait, is every number in the array unique? No, it is not. Maybe we could do something like this, where we'll start with the value, these are the actual indices from 376 to index 9511. So what if we save the values in the hash, right? I'll remove this cache stuff because it's just not enough. what if it looked something like where in the hash rate something like 180, right, going to 9926, right? Let's just say the range we were supposed to calculate was 136.9199. 136 to 9199. So let's just say we already have 189.926 in the hash, and some easier method or way. Maybe we could say, okay, well, we'll start summing up the values 136 plus 137 plus 138 all the way up to when we see, oh, hey, there's a value in the hash, which would be 180, and it would get us all the way to 999.9926. So maybe we could check whether or not the end indice is greater. The end indice is greater than our end, and if it's less than our end, it can help us skip some distance. But if it's greater than our end, we'll just keep going, basically. So basically, we can boil this down to if index in hash and end index less than right, skip to that index. To do that, all you have to do is change this to while left is less than or equal to right. What we're going to do is if the hash has a key for left and hash sub key, right, which means I have to change the value in the hash, sub 0 and index and end index is less than right, the end index, we want to make sure that this index is less than this one, so we can skip to that. So we'd say that our is right less than or equal to hash sub key. If so, we can do left plus equal sub key sub 0, and then we can say sum hash sub key sub 1, and then we can keep going. And then the else will be that we'll just add one indice, right? The key doesn't exist, right? So we're just going, the left index doesn't exist, like it's not saved. We didn't even call it hash, we called it cache, which means, right, what we're going to do is add one value and move forward. Add one value to the current index's value to the hash. So we'd say sum plus equal at nums sub left plus equal 1. So it would just be regular addition. And cache we haven't done anything to cache, but I'm gonna check run just to see if it works by itself, because it should. And it says accepted, which is good because we're not saving anything right now. And now we should be able to save, right, hat or at cache. I'm going to keep start of where we started off with. We should have not modified it in the beginning because we just tried not to modify function parameters. But so start left would be equal to the end value, right, which is right, and the second value in this tuple is going to be the actual sum that we came up with. And then I think what we could do, now we actually I think there should be we still get TLE. And I'm using, and I'm using key here. I want to use left. I'm not using key anymore. Oh my god. Oh, we have type annotations now. That's actually really cool. Undefined method error for no class, no method error. Confused. I don't understand why this is giving me an issue. The variable's clearly not empty. Plus equal at cache sub left sub 1. Oh, I see what they're saying. No way, I don't. Add cache sub left would give you access into the array, and we're subscripting it with the specific. Undefined method. Wait, we do have a key for it. Doing sum, which is equal to 0, plus equal at cache sub left. Why is this giving us such an issue? I don't understand. Why is this coming up as empty when it does exist? Undefined method, bracket for nil, no class, no method error. This is just strange. How could we get the key for left, but not the key for the right hand value, the indice of the right hand value? Something's got to be wrong. Something has got to be wrong. Let me see. Maybe we have to add one because we're setting it equal to left sub 0, which would be the end. So for example, if we're going to skip from 0 to 0 and now be set to 0, we need to add one. 2, -1, -3. I don't understand. This problem has a lot of dislikes though, so worrisome. Left is equal to at cache sub left sub 0. Then we would do 0 to 2, save that value as start would be 0, the end would be right, which was 2, and the sum would be whatever that sum was. Now we're doing 0 to 5. We'd say, okay, do we have a key in the cache for 0? We do, and our right is 5. Okay. Less than or equal to 2. Maybe you want to do something like this, where now 5 would be less than or equal to 5, or 2 would be less than or equal to 2. Now we could add it. So now we'd skip to 2, we'd skip to 3 basically. Oh, well, no, if we set it equal to the value, right, then we would have done the work, and then the next, we set it equal to 2, let's just say. We set it equal to 2. We go back through. What is going on? I think we need a better test case to test what I'm trying to test here. We have these numbers here. I first want to go from 0 to 3 and then go from 0 to 5. So if we go from 0 to 3, it might just be this whole sum thing right here. Then we get undefined. I don't understand why that's happening. We're making sure that the cache key exists. I wonder if it's the fact that the string could be, if the number as a key is giving us an issue. 0 to 3, 0, 1, 2, 3, get 5, you should get -2. Oh no, it's -7. You should get -4. Then we go 0 to 5. We see that 0 is in the hash. We have a key for it. And that cache sub left sub 0, our end index, which is 3, is less than or equal to 5. Then we say left would be equal to end index, which would be 3, and sum would be equal to 4. So 3 is still less than or equal to 5, so you go back to the top. We say, okay, do we have a cache for 3? We don't, so we say sum plus equal at num sub left. 1, 2, 3, which is why I was adding 1 to it, otherwise the value is 1 more than it needs to be. The runtime for this is actually awful, but maybe it could be because we're doing the puts. Yeah, I think this didn't make any sense. I think this doesn't make any sense because the end index and the end value, now I'm destructuring it into 2 variables, but we were just doing at cache sub left sub 0 and sub 1 before, but for some reason destructuring it allows for this to work now, which doesn't make much sense. This doesn't beat many. Yeah, this is not a great submission. What if we did another version where we try to find the closest indice or the closest key in the hash to the end one that we're trying to get to? That way we could take away the bulk of our work and only have to do a small number of operations. For that, we could do a binary search to find the end index that is already in the range. Let's just say this hash or this array of tuples. And I feel like that would be faster. Maybe that's what we'll try tomorrow. But as for now, I think the time complexity of this, the worst case is that we have nothing in the cache, and then from which we would just do a linear time sum of the values up to and including the end index. If that is the case, I want to say linear time, but also linear space, since we could have any number of keys here, or 10 to the 9 or 10 to the 5 unique keys potentially, or 10 to the 4. So, but since this is called multiple times, I think that's where the complexity really goes down the drain. Yeah, I'm gonna wrap that one up there.